Okay, hey everyone. Today is day 7 of Advent of Code. Like I said yesterday, I'm trying to make these a little more snappy. So I've already read through the puzzle, I've downloaded my input. I think what I'm going to try first is the kind of, I think, naive or canonical approach to this, which is just make a numpy array which with a row for each crab, and then take a column for each horizontal position between the minimum and the maximum, and just find the absolute value of the difference between the crab's position and the column position, sum all those, find the one with the minimum, and return that. I'm sure there's some clever, fast way to do this, but that's what comes to mind first, and I'm kind of approaching these as just learning how to use numpy and stuff like that, so I'm not too obsessed with getting the fastest possible answer. But that's where I'm going to start writing, and if it ends up being fast enough, I'll walk you through that. Otherwise, I'll walk you through what else I come up with. Okay, I'm going to get started. Okay, that actually ended up being not so bad. So, oops, this VS Code. Um, so, what we end up doing is wow, this numpy is cool. I can see how everyone uses it. um, what we end up doing is first reading in all of the crab positions here, obviously, and I just use numpy's load text for that. Again, I'm using sysargv so that I can pick whether I'm reading in my test or my input file, make them into integers, and they're delimited by a comma. Then once we have all the crab's positions, it's relatively simple to take the minimum and maximum, and we know that the best possible position must be in that region, because if you go past the maximum crab, you're just adding 1 to every crab. So we know that the best position is somewhere between the minimum and maximum crab. And it's probably not ever going to be the minimum and maximum, but in the test case, it is 2. So you can't kind of a priori say it'll be somewhere in the middle. Then getting the range of all positions between the crabs, and basically doing the subtraction for every so, sorry, you make the range of the position between each crab, and then you use this function np mesh grid, which takes two 1D arrays and returns two 2D arrays that are the same shape of the the broadcast array of the two, so of the multiplied, or well, it's not actually matrix multiplied, but with one as the column and one as the row, basically. Then you can just subtract those to find the value. Yeah, I mean, like I said, I'm sure there's some algorithmic way to figure out like a starting guess so that you don't do, because the thing is we're calculating a lot of stuff at the, you can tell just from looking at this that the solution is not going to be past 7, right? If you, the maximum is 16, so the middle point is 8, and there are way more crabs below 8 than there are above 8. So probably if you wanted to be clever, you could do something using that observation. But the thing is, this is very fast and very understandable. And so even with the input, which is much bigger and tests a much larger range, it was very fast. So I'll be curious what other people come up with, but I'm pretty happy with this. So let's move on to part 2. Interesting. So this changes the difference function. So I'm still going to use the same approach. We'll call this part 1. This comment should be up here. So for part 2, I'm going to go fast mode, and then I'll explain to you what I do afterward. Okay, so what I ended up doing was a little different than what I expected to. So if you look at the, let's pull back up the prompt. So if you look at how the crabs consume fuel, the first step costs 1, the second step costs 2, the third step costs 3. So that's just the sum of the range, right? From 1. So if the first step costs 1, then basically it's the sum of the range from 0 to 1 minus, or from 1 to the distance traveled. So that's a range in Python, right? So that means that all I need to do is, we already have calculated the difference in positions, and before we were just returning those as the fuel, so basically summing 1 for each step traveled. But now we need to convert that to the sum of the range. And the way I did that is to first calculate for each distance how much fuel is consumed. So I need to find what my minimum distance traveled is, which is in my differences array, and then what my maximum difference traveled is. And then for each range along those positions, I need to calculate the sum of the range from 0 to that difference. So that's what's going on here. For x in range, and then plus 1, so that we calculate the last one as well. We calculate the sum of the range. Again, x plus 1 for that, because we need to include that final difference, because that last step is being taken. And then I use this function, which I didn't know about before, called np take, numpy take, which basically, for each element of the second array, you pull the element from the first array corresponding to that index, which is perfect because we've already memoized the differences, and they're all going to be, I didn't think of this, but we're lucky there's, we know there's going to be a 0 difference because at some point we're traveling along the crab position. But this only works because the index of my memoized array matches exactly, the 0th element is how much fuel it costs to travel 0 steps. The first element is how much fuel it costs to travel one step. So if I didn't have any crabs or any differences between 0 and 5, for instance, then the indices would be off. But that's not going to happen because we calculated every single one. And memoizing it this way is much faster than calculating that sum every time, right? You calculate the sum once, and then you just go look in your table every time. I'm, again, sure there's an even faster way to do this, but here's what I came up with. So that's it. That's day 7. So yeah, happy Tuesday.